everyone, welcome to the first module on Introduction to Harmful Chemicals. Here in this module, we are going to learn about exposure in relation to different professions, how a chemical become harmful or the dose response, and contamination pathways. As I mentioned earlier, exposure in women is more influential than in men. Because when a woman is unaware of harmfulness of a chemical, she may expose her whole family to a hazardous chemical. While if she knows how a certain chemical could affect, she'd protect her family from it. So here in this course, we focus more on chemical exposure in women. What comes to your mind when you hear the word chemicals? Is it salt, vinegar, soap, pesticides, or the factory? Yes, we all have different kinds of experiences with chemicals. Often, women get exposed to chemicals as housewives, as lab technicians, as researchers, farmers, cleaning staff, etc. Housewives use pest controls. Lab technicians are often exposed to hazardous compounds apart from pathogens. Farmers and floriculturists often exposed to chemical fertilizers and pesticides. Cleaning staff again get exposed to various types of cleaner products. Also, there are certain jobs that has a direct exposure to hazardous chemicals, such as lead-acid battery recycling, artisanal gold mining, and dental technicians that mix up amalgam. Although there are norms for occupational safety, they are often not practiced. For example, workers don't use safety gears and thereby get exposed. So, what really is a harmful chemical? We generally identify a harmful chemical by how our body reacts to it. For example, your dishwash can give you a certain skin condition, or the smell of your paint could give you nausea. Likewise, these chemicals are related to certain health effects, such as irritation, skin burns, respiratory difficulties, eye damage, and toxicity to organs, etc. There's a famous saying by a Swiss physician and a chemist called Dr. Paracelsus. All things are poison and nothing is without poison, only the dose makes a thing not a poison. In short, we say the dose makes the poison. Which means that something to be a poison, it needs to reach a certain dose. So any chemical could become harmful if it exceeds the recommended intake. Not only that, there are certain factors that contribute for something to be toxic. Dose, or the concentration of a substance you got exposed to. Duration and frequency, which means how long and how many times you got exposed. The route of exposure, whether you got exposed through mouth, skin, breath, or injecting. And characteristics of a person, such as how strong is his immunity, whether he takes enough nutrition, whether his hormones are working properly, how old is he, whether it's a man or a woman, whether he is healthy or have any long-lasting diseases, and so on. It may be funny to hear, but according to this theory, even water can become harmful if you drink some 3 to 4 liters over a few hours by exceeding the tolerable limit. Any health effect related to exposure could be either a short-term effect, like what you feel or get as soon as you get exposed to a certain chemical, or there could be long-term effects that you get after certain years from the exposure. For example, person who works in an asbestos factory may develop the symptoms of mesothelioma when he retires from work. So you see that chemicals can become hazardous by their exposure in small concentrations over a long period of time, which we call chronic poisoning, or by their exposure to a large quantity over a shorter period of time, that we call as acute poisoning. Now, if you look at this table, you can see that acute and chronic exposures have different health effects. This table is only to give you an idea that depending on the exposure time and quantity, the health effects also varies. So don't bother too much if you are unfamiliar to medical terms given here. But did you notice that some have only chronic symptoms? The cocktail effect, or the effect of chemical mixtures, is a scenario we face today. It says when we get exposed to many different chemicals inside our body, they can enhance or reduce the negative or positive effects caused by each of them. Let me give you a simple example. Phthalates are a group of chemicals that mess with our hormones, or the endocrine system we call it. Sometimes having exposed to phthalate alone may not create this effect. But if you get exposed to all phthalate from your lipstick and bisphenol A or BPA from your plastic cup and dioxin in burning plastic, and if these chemicals get accumulated in your body together, they can affect your hormone system. So this is why it's important to avoid chemical contamination as much as possible. Now, exposure route can be both direct and indirect. Direct is when we get exposed directly from the source. This could be through inhalation, that's when you breathe in something carrying a toxic substance. Through ingestion, that's when you eat or drink something carrying a toxic substance. For example, suppose it's your favorite lipstick that contains phthalate, a hormone disrupting chemical. And each time you apply that lipstick and swallow it, you ingest phthalate. You can also get exposed through skin contact. If your whitening cream contains mercury and each time you apply it, mercury gets absorbed through your skin. Or through eye contact. Also by injecting any chemical directly to blood or muscles. There are also indirect or environmental exposures. Here, the source releases the substance or the chemical into the environment and a person gets exposed via ingestion, inhalation or through skin contact. For example, your neighbor burns plastic and if you inhale that fume, then you get exposed to dioxins and furans generated as a result of plastic burning. Suppose you stand by a person who smokes and you get exposed to passive smoking or the second-hand smoke. Or suppose the lovely flower painting in your mug has lead in it. And when you drink a lemon tea or something acidic, you also drink some lead with it. The exposure route between the source and the destination could multiply in some cases. For example, a woman who uses a bug spray can get some on her hand, and if she touches her child with those contaminated hands, the child gets exposed. Her nails could have some residue, and when she cooks, she feeds the chemical to her whole family. Likewise, there are many more incidences of exposure, especially when it comes to women. This diagram here explains the indirect exposure. First, factory emissions, man-made chemicals and sprays used in agriculture, gardening or pest controlling release chemicals into air, water, soil or groundwater. Then these chemicals contaminate food and beverages, consumer items or animals and animal products which we consume or reach human directly through inhalation, ingestion, skin or eye contact. So it's clear. In this exposure pathway, instead of coming directly from the source, the exposure takes place through the environment. I hope you got a clear picture of exposure from this session today. Here are some links if you prefer to read more. In the next session, we'll talk about some popular consumer goods that are found as culprits carrying hazardous chemicals. Good luck with the quiz.